In this class, I would like to explain for the continuous time system and discrete time system. At here, the system means a sort of mathematical relationship between input and output. In fact, system transform the input to the output in somehow. Here shows the two types of system. One is a continuous time system. The other one is a discrete time system. The continuous system working like this continuous input is applied to the continuous time system, and this system transform the input signal to the output continuous signal. Similarly, discrete time system also take an input sequence and system transform the sequence to the output. Here shows some examples. The big difference between continuous time and discrete time is this one. Continuous time system described by the differential equations, but the discrete time system is described by the difference equation. This table shows that example. I assume that you may know that the terminal characteristic of resistor and capacitor. I would like to briefly explain what is the resistor and what is the capacitor. You may know that the Ohm's law says that Ohm's law describes the behavior of a resistor. If this is resistor symbol, if we apply voltage across the resistor, that's the voltage V, then the amount of current are proportional to the applied voltage. So we can describe that one into this Ohm's law equation. V divided by R is the current. Okay, I will write here. The amount of current flow through the resistor are proportional to the V, but inversely proportional to the resistor. So this one is called Ohm's law. So if you measure if you'd like to measure the current, then you can calculate. You need to calculate the voltage difference across the resistor and divide by R will give the amount of current. Another component here is capacitor. Capacitor store the charge. This is a capacitance value you just see. And if we applied voltage this much V, then stored charge Q are given by C times V. But the current of the capacitor are given by this way. dq of dt, rate of change of charge with respect to time. This is the current definitions. So by taking differentiation with respect to time of CV will give C times dV of dt. In this circuit, the current flow across through the resistor and capacitor can be calculated by these terminal characteristics. The first equation, you know that the voltage across the resistor is Vi minus Vo will give the voltage difference across the resistor. So divided by R will give the amount of current by the Ohm's law. The second one is this equations. The capacitance current can be found C times V is take derivative with respect to time. That will give this value. C times dV of dt is the amount of current flow through the capacitor C. Resistor and capacitor connected in a series way, so the current should be equal. So the resistor current are equals to capacitor current. So this equation should be work. By dividing the capacitor value on both sides, then dV of dt are given VO over RC are equals VI. So the continuous time system can be described like this way. Y is the output VO dt are equals A times VY are equals B times VI X. So at these equations, Y corresponding to VO, VI corresponding to X. So system can be described by differential equations. You can see here this block are corresponded to continuous time system. So Xi are Vi, Y is Vo. So output voltage is Y, input voltage is Vi, and continuous time system is R and C. So input and output are related by the differential equations. Here shows a discrete time system here. In the discrete time system, Xn is applied at the input, output is taken at here. Here is 1 clock delay. Usually we are making this with D flip-flop. D flip-flop looks like this one. D is applied, data is input, and clock is applied here, and output is taken here. So data can be updated to the output at every clock. So this device means there is a 1 clock delay, one sequence delay. So if output Yn is here, then this means the previous data. In that case, Yn can be described by this way: Yn minus L plus Xn is the output. So Yn minus I equals Xn. In general, we can describe that one into this way: Yn minus plus Ayn minus L equals B times Xn. Okay, this is quite similar to this one. In the discrete time version, it is a difference equations. That's the discrete time systems. So physically, there is two different types of systems that exist. One is the continuous domain system. The other one is a discrete time systems. There is another thing we need to consider is the system connection. This shows the system diagram. 3 different connections are possible. The basic connection, the first one is the series connection. This is called the cascade. Sometimes we call the series connection. Series connection, 2 different systems are connected to cascade. Input is applied at the system 1 input, and the output of the system 1 is applied to system 2 input, and the final output is taken at the system 2 output. So this one is the input and this is the output. So these types of connection is a series or cascade connection. In the parallel connection, input signal is applied to both of the 2 systems. Both of the 2 system input applied like this way, and the output is added at the output terminal. So this types of connection is called the parallel connection. The last one is a feedback. Input is applied at here, and that is applied to the system input, and the output of the system 1 is tapped out and applied to system 2 and feedback to the input side. And some of these to input and feedback 1 and are applied to system 1. These types of connection is called feedback. In practical circuit, a combination of these connections, cascade, parallel, and feedback, are combined to working. So these 3 basic connections are frequently encountered in system descriptions.